Hello class, today we're on 1.4, the difference quotient and even and odd functions. So we're going to be talking about both of those today. Let's begin with the difference quotient though. So the difference quotient is what I have written here in blue. It's f of x plus h minus f of x divided by h. And it's a very important equation, especially when you get into calculus, because this equation is able to give us instantaneous rate of change, which is very important when trying to understand the world around us, and it's very, very cool stuff. So let's just work out the algebra for our use, okay? So let's say that we have some function f of x equals 4x minus 3. And I want to apply the difference quotient to it and simplify to see what we get. Now, if this is f of x, I have that here, but what is h? What is f of x plus h? Well, this will be f of x plus h. If you notice, every time you see an x in the original function, you just add a plus h in it, if that makes sense. It was originally 4x minus 3. Now it's 4x plus h minus 3. Okay? So now I'm going to plug it into this difference quotient here, and we'll go ahead and see what we get. So we first have f of x plus h, so it's this one over here. So I'm going to have 4x plus h minus 3 minus, and now for the f of x, I'm going to put it in a parenthesis or a bracket. Doesn't matter which one you do, because we're going to have to distribute this negative over. Okay? So very important stuff. 4x minus 3 all over h. And h, you just leave it like that. There's nothing we can really do with that. So let's go ahead and simplify this. If you notice, we can also distribute this 4. So let's do that at the same time as we distribute this negative, all right? So 4 times x is going to give us 4x. 4 times h is going to give us plus 4h minus 3. That's that minus 3 right there. And let's distribute this. Negative times 4x is a minus 4x. And negative times negative 3 is going to give us a positive 3. That's why it's very important to distribute that negative to that second term, because notice it changed signs. And then all over h. Now, the nice thing about this is that we have a lot of stuff that cancels out. And that's one of the beautiful things about the difference quotient. Notice that we have 4x and a minus 4x, so those cancel. And we have a negative 3 and a positive 3, so those cancel. Well, what do we have left here? All we have left is the 4h over h. But what do I know about variables, factors, when we have the same factor on top as the bottom? Those cancel, so our variables can cancel. So our answer here is just 4. All right? And that's it. Let's take a look at another example here. Just kind of solidify what we're learning. All right, so now let's say that I have f of x is equal to negative 5x plus 2. All right. So I want to plug this into the difference quotient. Maybe it might be smart first, if you like, to find our f of x plus h. So let's go ahead and do that. F of x plus h is equal to negative 5. And then remember, every time I have an x, I'm going to put x plus h. Just like that. And plus 2. So now let's plug it into this difference quotient up here. So I'm going to have f of x plus h, so I'm going to have this one over here. So negative 5 x plus h plus 2, and then minus my f of x. Remember, I'm going to put f of x in brackets because I'm going to have a negative that I'll need to distribute. So negative 5x plus 2, all divided by h. So let's go ahead and distribute this negative 5 to this, and let's distribute this negative to both of these in f of x. So negative 5 times x is negative 5x. Negative 5 times h is minus 5h, plus my 2, that's just this 2 right here. And then negative 2 times negative 5 is plus 5h, or 5x. Then negative times plus 2 is negative 2. And then all over my h. And again, you'll see we have a lot of stuff that cancels out here. So I have a minus 5x and a plus 5x. I have a negative 2 and a positive 2 and a negative 2. So all I'm left with is negative 5h over h. And again, we know that since these are both factors, we can cancel our h's out. So we're left with negative 5. All right? So that's all we need to do for the difference quotient. Just plug it in and simplify. So let's go over to our even and odd functions here. So even and odd functions, you may remember this from last year in Algebra 3-4. An even function is a function that has symmetry across the y-axis, and an odd function is a function that has symmetry across y equals x. But let's think about it analytically here. Let's not think about it graphically. Let's think about in terms of algebra. So this is how we're going to determine whether a function is even, odd, or neither. We're going to want to plug in negative x for every time that we see an x. Now, once we do that and simplify, if we get the same equation, it's even, meaning all the signs are still the same. If we get the negative of the original, it's odd. A negative of the original would mean that all signs are different. So all positives become negatives, all negatives become positives. And then the third option is if we get a different equation altogether, it's neither. So maybe some of the signs change, but some of them don't. Okay? So that's our criteria for determining whether something's even, odd, or neither. So let's take a look at this example here. We have f of x is equal to 4x plus 2x plus 3. And what I'm going to want to do is I'm going to want to plug in a negative x for every time I see an x and simplify. So I'm going to, I guess I could use different colors here. This first one, I'm going to put negative x to the fourth plus negative x squared plus 3. Okay. So let's see here. Negative x to the fourth power is really, I'm just going to do this scratch work off to the side, is really negative x times negative x times negative x times negative x. So it's just going to remain x, right? It's going to remain x to the fourth. But let's see what happens to the signs. Negative times a negative is a positive. Another negative times a negative is another positive. Positive times positive is positive. So recall that rule. Whenever we have a negative to an even power, I guess we could write that off to the side. A negative to an even power will become positive. Always, always, always. Likewise, a negative to an odd power will stay negative. So just keep that in mind. So here, it's to the even power. So this is going to just be 4x, or sorry, x to the fourth, plus this one, negative x squared. That's negative x times negative x. We determined here that it's going to be positive, and according to this rule, it's going to become positive. So that's going to be a plus x squared plus 3. Now, did the equation change for us? No, it stayed the same. So because it's the same equation, it's going to be even. So this equation is even. Let's take a look at a couple more examples here. All right, let's take a look at f of x is equal to x cubed minus x. So again, I'm going to plug in negative x for every time I see an x. So here we will have negative x cubed minus negative x. Okay? Again, every time I saw an x, I just plugged it in, right? Now, negative x squared, that's going to become positive x, right? Just how negative 1 times negative 1 equals positive 1. So this is going to become just x squared. Minus times a negative x is going to become positive. Oh, oops, I goofed here. This was a third, huh? This was cubed. It's supposed to be a 3, so is that. Okay. I'm sorry, that was a translation error. Okay, so a negative x cubed, well, that's going to be negative x times negative x times negative x. Negative times a negative is a positive. Positive times a negative is a negative x. So, according to our rule, it's true. A negative to an odd power will stay negative. So this is going to remain, or this is going to become negative. So it's going to be negative x cubed. And then distribute this negative. Negative times negative is going to be a plus x. Now we need to ask ourselves, did signs change? Yes, they did, right? But did they all change? So let's check. This was a positive, became negative. This was a negative, that became positive. So all of the signs in our equation changed. Because that happened, it's odd. It's the negative version of the original. So this is an odd function. Not strange, odd. Huh, okay. All right, let's do one more. Now let's say that I have, let's see, I'm liking the screen. Okay, let's say that I have f of x is equal to x cubed minus x squared plus 1. Now I'm going to plug in negative every time I see an x. Sorry, I'm going to plug in negative x every time I see an x. So this is going to become negative x cubed minus negative x squared plus 1. This blue keeps want to roll back. Okay. So plus 1. Now let's simplify. Well, this is to an odd power, right? So it's going to stay a negative. So this will be negative x cubed. Now, be careful here. This is how we're going to want to do this. Ignore this negative up front first and just focus on this. So a negative x squared is going to become positive x, right? It's going to become positive x squared, but this negative is still out front. Do you see that? So looking just at this portion, this is going to be a positive x squared, right? But because we have this negative, it's going to be negative, if that makes sense. And then finally plus 1. So let's take a look at this. Now I noticed some signs changed, but did they all change? Well, This positive becomes a negative. This negative stayed negative. And this 1 is positive, stayed positive. Now, since they didn't all change, some signs the same, some signs are different, this one is neither even or odd. So we would just classify it as neither. Okay? So that's all I have for y'all. We covered difference quotient and even and odd functions. Let me know if y'all have any questions, and I'll be here. Have a good day.